Hi there, I'm Borna, your organic chemistry tutor, and today I brought you another solved mechanism problem. Let's get started on it. Alright, so for today's mechanism, we have this reaction. If you have learned the alcohols chapter, I highly recommend that you pause the video right now and give it a try on your own. You should be able to do it, and then come back and see if you did it right. Alright, let's see how the solution looks like. First of all, when I look at the structure of the starting material and compare that to the product, it appears to me that this six-membered ring is very much in place. Like, not much happened to it. Okay, so I'm gonna highlight these carbons with blue, and that oxygen to it seems to be in place. That being said, this pink carbon seems to have ended up here. I kind of think that this is probably this other CH2, which, if that's the case, that means that this brown carbon has to have ended up here, which kind of does make sense because that's the one that is connected to a methyl and a methoxy in both the starting material and the product, so they kind of resemble one another. Plus, if I'm wrong with labeling, that's totally fine. I can always go back and change my numbering or labeling. First of all, let's see what makes sense to happen. We have acid present in the reaction mixture, and one of the quickest reactions ever is protonation and deprotonation of oxygens and nitrogens, because they go through a hydrogen bonding. So I kind of feel like since we have to make this other ring aromatic, let's get that over with. I'm gonna have my ketone here abstract a hydrogen and then remove a hydrogen from its adjacent carbon to create a double bond there and make my ring aromatic there. So let's see. We have that, we have this. Everything else remains the same. And then if I have, say, water, for instance, abstract a hydrogen from here. Now my ring is aromatic. Okay, great. This seems to be a reasonable first few steps for this mechanism, and this brought us pretty close to the product. Now, it seems like this OH that I just created has to get connected to the brown carbon. Now, how is that going to happen? I have an idea. Well, this bond is pretty electron rich, this double bond I mean, and it can abstract a hydrogen pretty easily because the methoxy pumps electron density into it. In other words, the carbocation that is going to generate as a result of that abstracting the hydrogen is going to be stabilized by an adjacent oxygen, which is very favorable. So let's draw that. So I'm going to have something looking like this, which is great because now if I have my oxygen attack this, which is the carbon of that carbocation, or oxonium to be more precise, that is going to give me my product plus a hydrogen. Now all that needs to happen is that something, perhaps a molecule of water, has to come and abstract that hydrogen. Now, let's see what kind of ring it's going to make. 1, 2, 3, 4, 5, 6. Okay, I'm going to create a six-membered ring here. I have my methyl and I have my methoxy here. And I have my extra hydrogen here, which is going to be abstracted by water. And that is going to give me the final product. Here we are. Was not that difficult. I hope you liked this video. If you did, don't forget to hit the like button. That's going to help me a lot. Also, please subscribe if you'd like to see more tutorials, solve problems, and tips and tricks. I see you in the next video.